Okay, back to the video. We're going to be looking at solving nonlinear simultaneous equations graphically now. So in lots of questions it will say using your graph. So often this is using the graph you've already drawn, and you won't be drawing any more curves. You might add some lines to this graph, but you won't draw any more curves. We've already drawn the curve y equals x cubed minus 3x squared plus 2, and we're going to be using that curve, that green curve that we've already drawn, to answer these questions. So in general, to solve linear equations graphically means to find values of x when the lines and the curves intersect. So when they cross. So we're going to be solving using our graph x cubed minus 3x squared plus 2 equals 0. This is what we're going to be trying to solve. This is an example question. Now on the left hand side of that equation we have, say, y equals x cubed minus 3x plus 2, which we already drew in the previous video and appears as that curve in green. On the right hand side we could say we have y equals 0. And what we're looking for is when these two equations are the same. We're looking for when the equation y equals x cubed minus 3x squared plus 2 is the same as y equals 0. When are these two the same? That's what we're solving, really. So we've already drawn the curve y equals x cubed minus 3x squared plus 2, and we could draw the line y equals 0, and then when we solve them graphically we're just looking at when they cross. The line y equals 0, well, just think about what that line is. That line y equals 0 is just the x-axis. On the x-axis, the y value is always 0, so I'll just highlight that now. Okay, so that line there, that purple line that I've put in, is the line y equals 0. We're looking for when that purple line crosses the green curve x cubed minus 3x squared plus 2. So we could mark those points of intersection. We have 3 points of intersection, and those points of intersection are the values x equal minus 0.7, x equal 1, and x equals 2.7. Okay, so we could change. This is how we've solved this question. We've looked at when, to solve this equation, we looked at when the curve y equals x cubed minus 3x squared plus 2 crosses the line y equals 0. And then we solved it to find these 3 points of intersection. Okay, now I'm going to look at a different example and maybe get you to pause the video and try it yourself. So maybe we could change the question slightly. So instead of having x cubed minus 3x squared plus 2 equals 0, we could have x cubed minus 3x squared plus 2 is equal to 2. So what changes? Well, what changes is we're now looking for when the curve y equals x cubed minus 3x squared plus 2 crosses the line y equals 2. Okay? So you should now, you may have seen it already if you were eagle-eyed, but you want to draw the line y equals 2 on the axis that we've already got. So maybe add that line now, y equals 2, to the axis we've already got. So y equals 2 is a horizontal line, and it should look like that. Now the question is, when do these two lines cross? When does that orange line cross the green curve? So maybe pause and work that out now. Okay, so the x values when the green curve crosses the orange straight line y equals 2, that happens at x equals 0 and at x equals 3. So that solved it. That point there were 2 points. We had this point here, x equals 0, and this point, x equals 3. So that was solving those two simultaneous equations graphically. Right, we're going to extend this idea now, make it maybe slightly more complicated. So please bear with me. Okay, let's have x cubed minus 3x squared minus 4x plus 4 equals 0. Great. Now notice that when we drew the curve, we didn't draw anything like this curve. Well, it was a bit like this curve, but not quite. We drew the line y equals x cubed minus 3x squared plus 2. That's what we drew. We didn't draw y equals x cubed minus 3x squared minus 4x plus 4. We didn't. And we certainly wouldn't want to draw that curve now on our graph and look at when that curve crosses the line y equals 0. It wouldn't make sense. We've done too much hard work already to make that a valid question. So we're not going to answer that question. We're going to adapt and change it. Okay? So, we haven't got this. We haven't drawn this, as I've said. What we have drawn, though, is y equals x cubed minus 3x squared plus 2. Okay, so we're going to use that. We're going to use our graph. So that thing I highlighted, that very first bullet point, use your graph. We're going to use our graph that we've drawn. And we want to make the left-hand side of the equation look like this. Okay, so when we make the left-hand side of this equation look like x cubed minus 3x squared plus 2. So what we could do to make it look like that, okay, we could say add 4x to both sides. Now it looks a little bit, it looks closer to x cubed minus 3x squared plus 2, but not quite the same, so we're going to have to take away 2 from both sides. So all I've done there is done some algebraic manipulation. So I've taken the equation they gave us, and I've rearranged it, and I want to use our curve that we've drawn, so I made the left-hand side look like x cubed minus 3x squared plus 2. By rearranging, I get x cubed minus 3x squared plus 2 equals 4x minus 2. Now the left-hand side looks like y equals x cubed minus 3x squared plus 2, and the right-hand side is y equals 4x minus 2. Now we should know how to draw this straight line y equals 4x minus 2. Okay. Y equals 4x minus 2 is a straight line that goes through the y-axis at minus 2 and has a gradient of 4. So what we're looking for when we solve these two equations graphically is when these two, this line and this curve, when they cross. Okay. You could draw a table of values to draw the straight line if you weren't sure. So let's try that now. So this is a table of values for 4x minus 2, but we already know it has a gradient of 4 and crosses at minus 2. So I've put 3 points on the graph now, and we're going to join them up. Okay, so that black line there is the line 4x minus 2. We're looking at when that black line crosses the green curve. That's solving something graphically, and it crosses at 3 points. Okay, so what are the x values when it crosses? Well, it seems to cross at x is approximately minus 1.4, x is approximately 0.7, and x is approximately 3.8, something like that. So those pink crosses I've read down and I've looked at the x values. Okay, so this is what it means to solve something graphically. It's quite complicated, but we'll be looking at some more examples in class on it soon.